Good morning, everyone. I just went to wash myself 7 or 8 minutes and people started creating chaos. There was a previous meeting and then the host comes and ends the meeting. Once you have you have become the host and started the meeting, you shouldn't end the meeting until the class ends. Okay. So that creates some chaos. Anyways, who's the new host? I have updated the post in the Google Classroom. So if anybody failed to join previously because the host ended the meeting, he or she can use the new link. Okay. So, okay, Tanvir Hossain Ananto, you are the host, okay? Ananto?
Yes.
Okay, so when I ask you to start recording, and at the end of the class, when I give the post in Google Classroom, remember to upload the video link there after changing the permission to public, okay?
Yes.
Okay. I'll wait for like 2 to 3 minutes since you have since the previous meeting was ended to so that all of you can join, and then we'll start the class. Is my screen visible?
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
so Ananto, start recording. Have you started recording, Ananto? Okay, the recording has started. So I believe we can begin our today's class. So before going into this topic, our today's topic is basically passing pointers as arguments to functions and then getting pointers as return value from the functions. But before going into today's class, or today's topics, let's look into the topic that we have discussed in the previous class. And also I'll do one correction. I made a mistake there, so I'll also correct that one. Okay. So basically, we're talking about pointers or the basic of pointers in C. Now we know pointers are nothing more than a special data type in C to hold memory addresses of different kind of variables or other objects. Okay, pointers can hold memory address of anything, and for each different type, it may be the basic types or it could be even derived types, like the types that we create. There can be pointers. Okay, and based on that type, the pointer. So defining the type is necessary, and there were, like I told you about, 4 use cases why pointers are used in C. So the first use case being dynamic memory allocation or heap allocation. The second one being iteration through contiguous memory locations, like in arrays or other structures in C. Third one being kind of simulate like pass by reference, so that we do not copy a lot or large objects. Okay, and keep only one like one copy of an object, or to like kind of simulate like multiple return times, which we will discuss in today's class. And the final topic being pointers to codes or function pointers. Okay, so pointers to function or function pointers, which we might take a look at next semester, or if we cannot, then it will be taught about it in your object oriented. You should be taught about it in your object oriented programming course. Okay, and this thing we'll take a look at next week, and this thing is next semester. Inshallah, this will cover next semester. This will be the main topic of next semester. Okay, one of the main topics. We will extend on that. Okay. So, anyways, and we learned about 2 new operators. Okay, 2 new operators. The first one being the address operator, which is used using the ampersand symbol, and the second one being the dereference or indirection operator. Okay. dereference or dereference or indirection operator, which we use using asterisk. Now, again, asterisks are used at two places. The first place when we declare a pointer, like integer pointer p, integer asterisk p, like this thing, integer pointer p. This one is not the dereference operator, but whenever we write like p is equal to 10, and maybe beforehand we write like p is equal to ni. So this is the dereference operator. So be careful in these places that so that you do not mess up with like the indirection and the declaration of pointers. Okay, so now I'll correct the mistake that I made in the previous class. That was like I said, like I have a pointer, integer pointer p, and I have an integer. Let's say integer I is equal to 10, and then I write p is equal to and I. So can I do something like this, like or like directly can I do something like this? And I asterisk and asterisk is equal to 50. Like let's forget about the p for now. Is it allowed or not? I said it will not work. No, but it will work. Why? We know whenever we write like asterisk p, this thing, whenever we write like asterisk p, basically it means go to that address that p is holding, and whatever there is, work with that one. You can get that one or set that one. Okay, asterisk p. So basically asterisk p in this case is exactly equivalent to I. Asterisk p, not just p, asterisk p. After dereferencing, it is exactly equivalent to I. So that's why it will work. Like when it is in the left side of the equation, okay, when it is in the left side of the equation, it works as an L value generally or as a variable. And whenever it is in the right side of the equation, it can work as a value. Okay, basically, so what happens whenever it is in the left side of the equation, it works as as a variable, and inside the right side, like if I write asterisk p is equal to asterisk p plus 1, what is actually happening here? So you can think of it like this way, like p has the address of I, so when I dereference it, it will be like I equal to, then this will also be like I, and then I. So since this I is in the right hand side, I will fetch the value of I, which was 10. So I is equal to 10 plus 1 is equal to 11. And left hand side, since it's in the left hand side, it will remain the variable and the value will be stored there in I. Okay, is it clear? So if you do it like this one, like multiple things, now and I, that is the address of the I. So this is basically equivalent to like p is equal to and I. So that's the address of I. So this now becomes another address equal to 50. And now since there is an asterisk and an address, if we make like if we resolve this one, it becomes like and an L value or and a variable. And this L value is basically I, because that was we are using the address of I is equal to 50. And again, and of I, this will become asterisk of another address, which is the address of I is equal to 50. And finally, it will become another L value, which is actually I equal to 50. So is this thing clear?
Yes, sir.
We,
So
we
in the
can,
book, it is written that asterisk and ant they are like negate each other. So
they kind of like negate each other. So the thing is that like in mathematics, sometimes what we do, like 10 divided by 20, we just like, okay, cut thing is thing, and we write 1 by 2. Okay, so like we do these things informally to understand ourselves, but what is actually happening here is that we're dividing this by 10. Okay, and we're dividing by this by 10 as well, because 10 is the GCD of these two, and then it becomes 1 by 2. So that's what is actually happening. But sometimes we say that okay, they can like if I write like 10 into like 20 by 10, we're like, okay, 10 10 cuts, 20 20 cut. Like there's no such thing as cutting in reality. What is happening, like if you take the like common things, and if you divide them or multiply them, the answer comes as like, if you multiply 200 by 10, it becomes 200, then 200 again, and the GCD of both of them are 200. So if you divide them, it becomes 1 by 1. So similarly, we say that they negate each other, kind of like negate each other. Yeah, that's true, that's what happens. But ultimately what happens, this thing converts to address, and this thing reverts back from address to the L value or the variable. So from the viewer's perspective, it's like, yes, they negate each other. Okay.
yes, sir.
Then if we can move on to today's topic. So our today's topic is basically, first thing that we will learn is pointers as arguments. Okay, so we will pass pointers to functions. Okay, so before discussing it, let's talk about a real example. Let's say we want a function, our decompose function. Okay, our decompose function. What will the decompose function do? It will take a fractional value, okay, a value with a number with digits after decimal point, okay, a fractional value, and then break it into integral part and fractional part. Okay, fractional. So if I want to give an example of this thing, like what it will do, let's say we have a number like 3.1415. This is the number that we have, and we want to pass it through the decompose function. Okay, decompose function. It will return give us two things. Okay, the first thing being just 3, an integer, and the second thing is the value after decimal point. We just want to decompose it. Okay, so is it clear what this decompose function doing to everyone? Is it clear? Okay. Okay, I'll consider that it is clear to you. So now we can definitely take a look at a pattern here. The thing is that whenever we use something like we want to find the absolute of the value, we call the ABS of a number, like let's say minus 14, and we got 14. Now in this, we are getting only one thing back, right? Or generally function returns, or in C, function can return only one value, only one. Okay, basically in any programming language, a function can return only one value in reality. Okay, so a function can return only one value. However, here we're seeing that, okay, no, we need two values from the function, first one and the second one. We require two values. So how can we make the function do this thing? The answer is basically point. Okay, so let's take a look at the example. Let me write the code. Let's say now in that case, we will not return anything for the function, and the function is called decompose. First, we will take a double value, okay, double value, which we will decompose into an integer and a fractional part. And then instead of like, let's say we have two things, first of all, like integer int part, okay, and then we have another double back part. And we have, let's say for now, we have somehow implemented the function here, okay? And let's say I have an integer, like integer, sorry, we have a value like double V is equal to 3.1415. And we declare an integer, let's say I part, and we declare a double, let's say F part, fractional part, okay? And then we call the decompose function. We will fill the decompose function, give me a moment, and just pass the value I part and F part. And let's say inside this decompose function, what's the problem here? So let's say inside this function is it does the decomposition of value and then assigns them to int part and fractional part. But we cannot get them back, right? Why? Because we know in C, arguments are passed by value. That means the values are being copied. So what is happening? Let's say if I part initially holds the value 0 and fractional part holds the value 0.0, or let's say just for clarity 0.5, when we call this function 3.1415, a copy of 3.1415, okay, not this V. A copy of 3.1415 gets passed in this place. A copy of 0, like a copy of I part, gets passed here, and a copy of F part, like 0.5, gets passed here. A copy. So if we modify like in part, frac part, that copy that are made for this function scope are being modified. However, the actual variables are not being modified. As a result, we cannot get those values back. What is the solution to this problem? Instead of declaring these as just variables, instead, let's take a copy of their addresses, a copy of I part, a copy of F part. So we will make them integer pointer and double pointer. Okay. So, integer pointer. And we know that values are always passed as copies in C. So ultimately copies are being passed, but what copy of what are we passing? We're passing the address, not the variable themselves. Now, the work is pretty easy. Like, let's say int part, and we are dereferencing it. We are going to that address and using that variable. So if we dereference this address, it will basically point to the variable. It will basically represent the variable IPERT, okay? That original one, because we have gone to its address, is equal to, we will just cast the double value to integer, okay? So what will this do? Like if the value was 3.1415, after casting it to integer, okay, after casting it, it will be truncated to only the integral part. So it will become 3, okay? So integer part is equal to int value. And what we can do, we can write, like, again, dereference fact part, okay, is equal to, what we can do, we can take the original value, which was 3.1415, and from there subtract the integral part, which we derived in the previous line. So what is happening here? The assignment is basically like value is equal to fact part equal to, like, dereference fact part is equal to 3.1415 minus 3. From the previous line, we determined it to be 3, and it is happening like 3.1415 minus 3 is equal to, which we can write like 0.1415. So did you understand, like, how are we extracting the integral part and the fractional part from a double value? Is it clear?
Should we use ampersand in argument?
Wait a minute. We will correct the argument part later. For now, focus on this part, okay? The program is not finished. It focus on just the function. Is this thing clear to you guys? Yes or no?
Yes, sir.
Yes, sir.
Is it no for anyone? In that case, I'll try to re-explain. So we have dereferenced it, which is now acting like a variable, and we have kept the integral part of the value, which is like, if we pass 3.1415, it will be 3. And then to calculate just the fractional part, not the integral part, we're taking the original double value, which was 3.1415, and from there subtracting the integral part. If we subtract the integral part, the thing remaining is only the fractional part, which is 1415. So we have stored them. Now, since these are functions and we have gone to the original memory location and made some modification, we do not need to return anything. The original memory has been edited. Okay, the original memories have been edited. Now we just need to do one minor change. Like, now this function actually requires address, not a copy of the value of the variable, a copy of the address. So as a result, what we can do, we can write ampersand sign before IPERT here. It will pass the address of the variable, and we can write ampersand sign before fpart, and it will pass the address of the variable fpart. Now, if you take a look at the value and print them out, printf, this is the whole value, percentage f. Then we can write like the integral part, okay, integral part, and then we can write the fractional part, percent f. Let's do it with percentage g. That will become clearer. Okay, and backslash n, and we'll pass like v. Now just the copy of the value IPERT, and then f. Okay. Now if we compile and run this program, the whole value is 3.1415. The integral part is 3, and the fractional part is 0.1415. Now let's take a look what is actually happening visually. Now, I have a value which is 3.1415. Okay, I have an integer variable called IPERT. I have a double variable. This one is also double. I have another double variable called fpart. Okay, and we have called decompose function with value IPERT and fpart, okay, and address of them, not the real thing one. So if you take a look at the function here, okay, so the decompose function takes a value, a copy of the value. That's fine, we know it's a copy. And then there are two pointers in this function, integer part and frac part. Okay, so the pointers are like this, like int part, which is a pointer. Initially, let's say they put some garbage value, okay, not something necessary. And these are pointers, and then we have another pointer, frac part, Okay, both of them are pointers. Okay, both of them are pointers. Okay. Which points to another some other garbage value. And here we have passed and ipert and fpert. So what is actually happening after we pass their addresses? Let's say ipert has an address value of, let's say, 2020, and fpert has address, not their original values, okay, not the numerical values, their address values of 3030. Whenever we have written ipert and here and fpert, we are basically passing the values 2020, the address values, and 3030 here. Now this thing contains the value 2020 integer pointer fracpert, and this thing contains the value 3030. So what is this thing pointing at now? Intpert. What resides at 2020? Which variable? Sorry?
Ipert.
Yes. So this will now point at the variable ipert. Okay. And this will point at the variable, which one? Fpert. Okay. Now, if you write something like asterisk inpert is equal to 50, what are we doing actually? We're dereferencing inpert, right? The dereference inpert will mean go to this address, go to 2020 address, go there and modify the variable there. And which variable residing there? Ipert, right? If you write asterisk inpert is equal to 50, basically we are going to that address and modifying the value of ipert to be 50. So similarly, when we pass the value 3.1415 here as the value and written something like asterisk inpert is equal to integer of value, which is casting. Okay, if whenever we have written something like this, what is happening? We are dereferencing inpert here, dereference. Okay, we are dereferencing inpert here and going to that place. And in that variable, we are assigning the integer part of the value or the truncated part of the value. So now we will go there and assign ipert to be 3. And similarly for the frac part, what we have written, dereference of frac part is equal to value minus dereference of inpert. So what is happening here? The value is plain forward 3.14. The value is plain forward, which is 3.1415. And about dereference of inpert, like go to the address of inpert. Okay, go there. Okay, we go to the address 2020, our hypothetical address, and find the value of that variable, which is 3. Okay, so we are writing 3.1415 minus 3, and we're getting 1.1415 and assign it to dereference of frac part, which means go to that address and assign the value there. The address is 3030, so we'll go there and assign the value 0.1415. Okay. Now we have actually gone to that address and modified the original value of the variables. Okay. So that's why we do not need to return anything back from the function, basically ipert and fpert. Okay, their original, like we have gone to their place in the memory and modified those values, so they are getting updated there. We do not need to return anything. We can just print them out after calling the function. Is this thing clear?
Sir, one question.
Yeah, sure, go on.
So we are modifying ipert and fpert, and we are passing their addresses, right? As
we are passing their addresses and then modifying them. The modification doesn't come first.
So my question is, so if we save the address of ipert and if
do one thing. Like, let's do one thing. Let's say we have an integer pointer called ptr underscore ipert. Okay, we have already saved their addresses, like okay, ipert. Okay, and let's say as a double pointer ptr underscore fpert, right? Okay, is equal to and of fpert. Okay, now take a look at, like, all of you take a look at these two lines. What we have done, we have taken the address of ipert and already copied it in ptr underscore ipert, which means the variable ptr underscore ipert holds the value 2020, our hypothetical address, holds the value 2020. Okay, the address of ptr underscore ipert is not 2020. ptr underscore ipert now holds the value 2020. It will have, and ptr underscore fpert holds the value, anyone? 3030, our hypothetical address 3030. Can we pass them to the function? Yes, we can. Our ultimate target is to just get these two values, these two addresses. 2020 and 3030 to the decompose function. So if we want to call them, now we do not need to use the ampersand operator anymore because ptr underscore ipart already holds the value 2020. And for this one as well, we do not need to put the ampersand. We just need to write ptr underscore fpart. Okay, that will be fine because if we use ampersand, using ampersand here will mean that, okay, give me the address of ptr underscore ipart, since ptr underscore ipart is itself a variable. So we do not want their address, right? We just want the value stored in there, which we stored, the address of ipart 2020. So that's why we just write ptr underscore ipart and ptr underscore fpart. They will get the address there and it is fine. Compile, and if you run the code, it's exactly the same. Actually, the funny thing is that if you yourself directly know the address, I have said that this is possible in case of building operating systems. The first few files, we put them at a specific locations, okay, inside your memory. In those cases, it is simple. Like if we know that the address is actually 2020, we can directly write 2020 here. The address is 2020. We can directly, like, I know for sure the address is 2020. So I can write that here. Generally, you need to cast it. Like you can say, you need to say that, okay, 2020, but 2020 is an integer pointer. So if you know the address for sure, you can write it this way as well. Like in case of normal program, it will not happen. You will not know the address. Only in case of like building operating systems or embedded systems, you might know the address. The final thing is you need to get the value of address there, not the value of the variable. However, you get the value of the address is completely up to you. Like you can have another copy, like integer pointer ptr copy, okay, is equal to ptr underscore ipart. If you remember the previous class, now basically both ptr copy and ptr underscore ipart are pointing to the variable ipart. And if you want to pass ptr copy, you can pass ptr copy. That will do as well. Okay? It's exactly the same thing. The ultimate thing is I want to get the address to this function, the address, not the value. By using the address and then dereferencing or indirecting it, I can access the variable from anywhere. Is it clear? Like in case of this thing, what is happening? Like I have like pointer underscore ipart, okay, pointer underscore ipart. Now it is pointing to ipart, okay, and then I have pointer underscore fpart, and it is pointing to fpart. Now I like, since if this, let's say initially it holds the value 0, it holds the value 0.5, and I'll write that in blue. This thing has the address 2020 and this thing has the address 3030. Whenever they are pointing, now the variable ptr, like whatever I write inside is the value of the variable, whatever I write outside in blue are the addresses of those variables. So this thing now holds the value 2020, fpart holds the value 3030. However, ptr underscore ipart, since it is a variable, it is residing somewhere in the memory, it also, let's say, have some kind of address of its own. Let's say it is 500 500, and since this is also another variable that is residing in the memory, it also have some other address of its own. Let's say 10 100 100, anything, that's some random value. Okay, so ipart has the value 0, fpart value 0.5, ipart has the address 2020, fpart has the address 3030. When we write something tr underscore ipart is equal to and ipart, what is happening? We are taking this 2020 value by using the and operator. By using the and operator, okay, we're taking this value and copying it to the variable ptr underscore ipart inside that variable. Similarly, fpart, we take the value by using the and operator and take the value and copy it to the variable ptr underscore fpart as its value. Now, in that function, the function ultimately needs the address of ipart and the address of fpart, the decompose function, which are 2020 and 3030. We have already copied the 2020, like ptr underscore ipart and ptr underscore fpart. So we can directly pass them. So whenever we pass them, what happens? This value gets and stored in like int_part as pointers. Okay, it gets copied and stored in int_part. This one also gets copied and stored in the pointer frag_part, copied and stored. Okay, but if we mistakenly pass like something like this, we put another and sign before the pointer. This is now not a variable, already a pointer, already holds the address. Now this will become actually wrong. What is happening now? We are taking this thing's address. Okay, we are taking this thing's address, basically 50-50, and we are taking this thing's address, and then we are putting them in int part. Like now, int part would hold the address 500, 500, and fact part, the parameters, okay, will hold the address 100, 100. These two parameters, we write something like this, integer part and fact part. They will hold the address 500, 500, and 100, 100, which is actually wrong, okay? These two things are wrong. These two addresses, we want 2020 and we want 3030. That's why we directly pass ptr underscore I part or ptr underscore f part, or otherwise we pass and I part or and f part. In those cases, we get 2020 or 3030 properly. So is this thing clear to everyone? Yes.
So now this is wrong, but what will happen if we pass asterisk then PTR part or PTR part?
P part pass.
Yeah, instead of the ampersand sign, if we put the asterisk sign, what will happen then? What value is going to pass?
What will happen? Okay, if you put asterisk sign. Okay, now this is also wrong. Now what are we doing? Okay, we're saying like instead of passing like this 2020 value, which PTRF part, and we are now doing like asterisk sign before it and asterisk sign before it. If we put asterisk sign, what does it mean? Go to the address 2020 and use the value residing there. Now we are passing the value 0, the initial value of I part, and we're passing the value 0.5, the initial value of F part, right? Is it clear?
Yes. Yeah.
Putting asterisk sign means dereference it or indirect it. Go to that address and use that one, right? So basically, this is exactly like this is equivalent to directly writing I part and directly writing F part, because we have dereference, which is again wrong. Not their values, like 0 and 0.5. Like first of all, we cannot use 0.5 as address, so that is out of question. That's why I've got an error here. And about 0, well, 0 is a valid address. This is now pointer, but we cannot modify the value there. Actually, in 0 is a special value. It will never change, like in that address. That's a dumping point. Anyways, so the thing is that, yeah, now we are wrong, right? We want to get their addresses. Our target is to get 2020 and 3030. That's why if we have hold them in a pointer, we already have the copy of the addresses there. We neither use the ampersand sign nor use the dereference signs. We just pass the values. Okay. Is it clear? The person who asked the question. Who asked the question? Am I audible or am I not?
Yes, sir, you're audible, sir.
Okay.
Yes,
Are
sir,
you
you're
people
audible.
are you people feeling unwell or something like that? Or did something happen? Are you people tired? Like you people are not responding. I'm asking whether you have understood it or not. Nobody is replying anything. I'm asking the person who asked the question, did you get your answer or not?
My network.
Okay.
I did understand.
Okay. So everybody understood. Yeah. Some. Yes, that is Safwan Haq.
Sir, would it be why are we indirectly assigning value to each of I mean the in part? Why can we just not pass to the function just e part, I part, and frac part themselves?
So
Why do we need?
I'll remove this one. Let's say in a decompose function, okay, I pass the value, and instead of passing the address of like in part, I directly pass the variable I part and I directly pass the variable F part. Okay, so what was the target of my, again, Zarif, what was the target of my function decompose? What would this function do?
Sir, to get the in part and a fraction
Yes,
part.
so it will break a fractional value into integer part and into fractional part. That is my target. Now, let's say I have a variable I part, which it was the initial value was 0, 1, and I have another variable F part 10. Okay, so if I write decompose of value I part, let's instead of calling it like in main function, they are not IPERT, let's say IP is equal to 1, just to give a different name, and FP is equal to 10. Okay, and we passed IP as IPERT here and FP as FPERT there inside the function. The function parameters are IPERT and FPERT. So what is happening here? One gets passed here, right? IPERT. Zarif?
Yes, sir. Yes, sir.
And 10 gets passed here. Okay. In decompose function, we wrote IPERT is equal to integer of value, right? And FPERT is equal to value minus IPERT. Okay. So IPERT now holds the value 3 if you pass 3.1415, and FPERT now holds the value 0.1415, right? Is it clear, Zarif?
Yes, sir.
Okay. IPERT holds the value 3, FPERT holds the value 0.1415. But does IP and FP hold these two values, 3 and 0.15? The original variables?
No, sir.
No. Why? Because in C, things are passed by value, means whichever argument you pass, a copy is assigned to the parameter. This is the argument, this is the parameter. So if you pass IP here, one value gets copied to IPERT and value 10 gets copied to FPERT. Now, how do we get these two values back?
Sir, we're printing.
No, the decompose function, the duty of decompose function is not to print. Again, the duty of decompose function is to give you 3 and 1.1415 in case of 3.1415. The decompose function is not printing. Again, separate your concerns. One function should do one thing. Like in case of an application, you print the decomposed part. Okay, that's fine. In another application, you do not want to print the decomposed part. You actually want to test the integral part and the fractional part. And then maybe you want to compare whether the fractional part is 0.5 or less than 0.5. Okay, if it is greater than or equal to 0.5, then I walk to the integral part and say that, okay, this is your like up value. You're writing your own rounding up function. Okay, 3 plus 1, 4 is your rounded up value. If it is less than 5, 0.5, then 3 is your rounded up value. Okay, I will not add anything. You are making a round function from it. In one case, you're printing the decomposed function, like decomposed values. In another case, you are using the decomposed value to do something else. Now, in computer science, you should not be copying or pasting your codes. It increases the length of your program, and it also introduces places where you can make mistakes. That's why we convert the whole thing into a function that does the main work for us, and then taking the output of the function, we can do different things. The decompose function should not print. The duty of the decompose function is just to give you back the integral part and the fractional part. Now, Zarif, answer me. If I do not pass the address, if we just pass the values IPERT and FPERT and modify like a IPERT, FPERT, how are we going to get back?
Sir, I'm not sure.
Yeah, there is no way to get them back directly. That's why what we did, instead of passing the value of the variable, we passed their addresses using the ampersand. Okay, now they become pointers. So instead of passing 1, if IP had the address 20 and FP had the 3030, what is being passed? Address, right? Now this one will not be 1. This one will be 2020. This one will be 2020, and this one will be 3030. Is this thing clear? When I pass AND IP and AND FP, the address are being passed to these pointers.
Yes, sir.
Okay, now the address are being passed. Now, inside here, what am I doing? I'm dereferencing the pointer. I'm writing asterisk IPERT, asterisk FPERT, and here also asterisk IPERT. Now, what does this mean? Asterisk IPERT.
So give me the value of IPERT, but that's what.
Go to that address and use that variable there, right? Go to that address, 2020. Go to that address and use the variable there. Now, if you go to the address 2020, what is the variable residing there actually?
IP and
IP. So by copying the address and not copying the actual value, you are now able to modify the original variable that was in the main function, right?
Yes, sir.
This one also represents FP, because we know during the lifetime of a variable, their address never changes. Okay. Then address will never change. Their value can change, but their address will never change. Now we are actually using the original variable here by copying their addresses instead of their values. So now if I do a modification inside this function, this modification will be reflected upon these original variables, right?
Yes, sir.
Okay, so now the value 3 and 0.1415, instead of being stored in these local variables, they are being stored here in the original variable, right?
Yes, sir.
Now we do not need to worry about returning any value. Why? Because instead of modifying the value of a new copied variable, we have actually modified values of the original variable.
Okay, sir.
Did you get it?
Yes, sir. I think I did.
So you need to practice.
Sir.
And also, yes.
Sir, I have a question.
Yes.
Sir, if we use a integer or double type function instead of void function, is it possible to get these two values
No.
separately return?
No. No. You can get only one value back. Like if you write an integer function, how can you return two values? You can return one integer value, right?
Yes, sir. I get it.
If you write a double function, you can return only one double value, right?
Oh,
Are there other ways to return multiple values? Yes, there are. We can create a structure, okay, and we can say that, okay, decompose a structure, and that a structure will be considered as a single data type, and it will have its integral part and it will have its fractional part, okay. So we can do something like that, but we'll take a look at them later, okay. What are structures? But this will make a copy, and this thing will not make any copy. This will modify the value of the original variable. So there are multiple ways. We will take a look at a structure next week, okay, inshallah.
Excuse me, sir.
Think. Yes.
So what if we wrote something like ipart is equal to int value, just ipart with no asterisk?
Okay.
So
now
would
what
that
will
actually
happen? Yeah,
update the
that will
value
be
of
wrong.
ipart,
No.
or would that do nothing?
What? Yeah. So asterisk ipart means go to the address 2020 and use that variable there, right?
Yes, sir.
Okay, which is the IP variable. Now, if I just write ipart is equal to int value. Now, what data type is ipart?
So it's an integer.
No. What data type is ipart?
Oh, it's an integer pointer.
Pointer.
Exactly. So it is supposed to hold some addresses. Okay. Now what will happen? ipart is an integer pointer, which is a local variable, okay, which is a local to this function. Okay, it doesn't exist outside. Now I'm writing ipart is equal to integer value. So ipart will basically hold the address 3 now instead of the address 2020. You modified that and written ipart is equal to the address 3. What will it do? Nothing.
Yes, sir.
Yeah, it will do some like wrong things. When you go to like this line fpart and you have assigned the address of ipart to be 3 and written value is equal to, then you will be writing, okay, value minus, go to the address 3. Go to the address 3 and fetch the value from there. Now, what is the value residing in the address 3? We do not know, because that memory doesn't belong to us. Okay, so there will be some garbage values there. Got it?
Yes, sir. Got it.
So that's why be careful and try to be logical. Like our target is to get the address. If we do dereferencing or like indirection on address, we will go there and use that variable. Just remember these two parts. And after, whenever you see some equation or to resolve this, what, okay, ipart is a pointer. That means it holds an address. If I put asterisk before an address, that means go to the address and use that variable. Okay, it is fine. In here is also the same. So I'm going to that address. And what address had I passed? I had passed the address of the variable IP. Okay, so if I do dereferencing on the address of the variable IP, I'll get IP. So that's why it says IP is equal to integer of value. Okay. Similarly, if I do dereferencing on the address of F, which was stored in fpart, I'll get FP. Got it? How this thing is working?
Yes, sir. Got it.
That's why I said one more thing, like whenever you need to pass the value, like pass the address. Do not pass the value, because if you pass some random value, like instead of passing an IP, if you just passed IP, you would have passed the address 1 and you would have passed the address, passed the value 10, but as address here. And this program will try to modify whatever the value is in the address 1 and 10, which does not belong to you. Remember, if we like, instead of passing the address like we have done here, if you had directly passed ipart Okay, here, like if you directly pass I part here and F part here, you would have passed like 3.1415 and then 0 and then 0.5. Okay, so you cannot modify the value at address 0 because that does not belong to you. You cannot modify the value at address 0. Actually, 0.5 is not a valid address. That's why it's showing an error. Like had it been some other thing like 1, like if had it been an integer, like you cannot modify the value there because this is not a valid address that belongs to you. So in this case, remember, whenever you're supposed to pass an address or multiple addresses, you are passing proper addresses that have been reserved by you. Like since we declared the variable I part and F part, now those addresses belong to us for modification in those addresses. So remember to pass wherever you're asked to pass address, you pass address, not value. Because if you pass value, that will be wrong. You'll be like you will consider some values as address and will try to do some modification there, which is actually wrong. And again, if you are directly passing pointer, you use pointer variable to hold the address already. Do not put ampersand sign before them again, because now you are, instead of passing the address of the variables, you are passing the address of the pointer that is already in the of the variable. A second step, like you showed, like I showed you previously, like the one with 100, 100 and 500, 500, those things. Okay. Like, yeah, instead of passing 20, 20 and 30, 30, you would then be passing 500, 500 or 100, 100, which is actually wrong. So in those cases, be careful. Now, can you tell me about a function where you have already used these concepts of passing pointers to get value? Used already? Like where instead of passing the value of a variable, you pass the address of a variable, and that variable, you receive some values there in those variables. Can anybody tell me about an example?
Arrays.
Not that. Arrays, yeah, arrays behave as pointers, but we'll discuss them in the next week. Let's say I want to scan two integers. We write scanf %d. Basically, this format string tells the scanf function I want to scan two integers. Okay. And then what do you write? And I and j. There. Instead of passing the actual variable, we pass the addresses of these two variables. That's why scanf function scans from the console, gets the value, then goes to the address of I. Like if you had inputted like 10 and then 30, okay, as your input. Basically, after doing some work to get the values 10 and 30, what scanf does something like %i is equal, asterisk I is equal to 10, and then asterisk j is equal to 30. That's what a scanf does. You see, exactly similar to the one decompose function that I've shown you. Is by using the address of the variable, we put the values in the variable that resides in those addresses. So scanf also does something like that. So if we like in scanf, we have always passed like and I and j, but if we like use some pointers like integer pointer p_i is equal to and I, and integer pointer p_j is equal to and j. In these cases, what we would have passed instead of I and j, like if you want to use the pi and pj, what should we have written?
Sir, npi, npj.
Why npi and pj? It shouldn't hold the and there. Okay, it shouldn't hold and there. It should just be p_i and p_j.
Oh, okay, sir. Yes.
Right? Why? Because we want to get the address of I
Address.
and j to this scanf function, and pi and pj already holds the addresses, right? Because they're
Yes, sir.
pointer variables. That's why we directly pass pi and pj. If we had written and pi and pj, it would have been wrong. And then what would have scanf done? Instead of like modifying the value of I and j, it would have made the value of pi and pj. If you had mistakenly written NPI and NPJ. There are other caveats and other errors with this one, but in simple terms, that's what scanf would have done. So there shouldn't be any and here. Okay, it should be just PI and PJ if you want to pass it with pointers. Yes, Samnun?
Sir, if we are declaring like integer asterisk IPI and like asterisk IPJ, aren't we like dereferencing the
No,
PI
again,
variable
I've
in
said
in
that.
that line?
No, I've said that this thing has two different versions. Whenever I declare something like integer pointer p is equal to and I, this is both declaration at the same time, right? Or I can just write integer pointer p and then p is equal to I. Remember, whenever writing something like this, integer pointer p, declaring them, in those cases, this defines the data type. Okay, this defines the data type. This doesn't define the value. This defines the data. Okay, this is not dereference operator here. Okay, and again p is equal to I, and here also both declaration initial. So this is the data type. Okay, this is the data type, integer pointer, and p is equal to and I. However, whenever I write afterwards, not at the place of declaration, afterwards, asterisk p is equal to like 10. Now this is dereference, okay, or indirection. So remember, there are two asterisks. One is the pointer data type that you will only see in like initializations, like only in declarations, okay, only in declarations. And this one is the dereference or indirection, and this one like at all other places, okay.
Okay, sir.
Other than declarations. Remember this thing. And address operator is address operator. Whenever you see and will be address operator, except in some places where it can be used as a bitwise and.
Sir,
Like
so
if
we have like a float pointer, then we can only dereference it and store float values in it.
Yes, a float pointer will point to a float variable, and whenever you dereference it, that means go to that float variable and use it, you will get a floating point value.
Okay, sir. Thank you.
But the float pointer itself holds an address, which is an integral value. We know that addresses do not contain any decimal point, right? Addresses are just integer values.
Okay, sir. Thank you.
That's why one more thing, like whenever you declare pointers, like do define their prototypes, so define their prototypes or declarations properly, so that if you pass something, like you're supposed to pass pointer, but you passed like directly the value, okay, in most cases it will be caught, okay. Otherwise, in some cases the compiler will catch it instead of this one. Like if instead of pointer ipart, if I just create an ipart and if I compile it, I'll get an error. I get a warning, like warning generate, like passing argument to parameter integer part here. Okay, so the thing is incompatible integer pointer passing integer to parameter of type integer pointer. In those cases, compiler will catch it. So remember to declare them. But scanf is a slightly different function. That's why when you miss the and symbol, whenever you miss the and symbol in scanf function, you do not get a warning generally. Why? Because I think Lang will catch it for you as well. Why? Because scanf is a special type of function. Those are called variadic function because they take a variable number of arguments. We will not learn about variadic functions here. After learning C completely and even maybe C++, if you wish to take a look at variadic function, you can take a look. Okay, but that's some advanced topic which will not be taught in this course. Okay, so since a scanf is a variadic function, it will not catch errors like that. So in case of scanf, remember to check whether you're passing the addresses properly or not by yourself. So similarly, if I ask you, okay, if I ask you to implement a function that gives you both the maximum and the minimum index, okay, like we have an array that contains some value and we want to find the index of the maximum and minimum value in that array. So what can we do? Again, we need two things, right? The maximum and the minimum index. So we can write it exactly like this, like find max min index. Okay, we'll take, let's say, integer array, okay, and since we will also need the length, okay, and we want the maximum and minimum index, right? So since we need two things, what we can do, we can declare an integer pointer, okay, which we'll call min index, and integer pointer max index. Okay, we can declare it like this. And what can we do? We can go down declare the function here, define the function here, and what we can write, like we can initially write, okay, dereference of mean index is equal to dereference of max index. We're using the variables is equal to, let's say, initially we assume the very first index, the 0th index, is both the minimum index and maximum index. Okay, and then what we can do, we can write a loop integer I is equal to 1, I less than len I plus plus. Okay, if array of I is greater than array of, well, dereference the max index. Okay. In that case, what we can do, dereference of max index is equal to I. Otherwise, else if, like, array of I is less than array of, like, mean index, we can write dereference of mean index is equal to I. Again, we are storing the maximum or minimum index in the original value by dereferencing their original variables, by dereferencing their addresses, and we do not need to return. Now, if you want to test this thing out, so we have an array, integer array, and let's say let's put some values there. 1, 4, 3, -1, 2. So the maximum index should be 1, okay, and the minimum index should be 3. So let's declare two variables to get back the max and min index. Let's say minimum I and maximum I, two variables. And what we can do, we can call the find max min index. We'll pass the array, we'll pass its length 5, and we'll pass pointers to these variables. Okay, minimum index and should be and not asterisk mni and mxi, and if we print them, printf mini %d maxi %d expression comma mni comma mxi. Now, is there any error?
Comma after that.
Oh, right, sorry. Yeah, that's it. Go there, file, run the code. You see, the minimum index is 3 and maximum index is 1. So did you people get how this function is working? Again, we have passed two addresses instead of two variables, the array and the length. And initially we assign both of them, okay? We dereference them, okay, variable. So dereferencing max index will give me the actual variable in the main function, which is equal to 0. And those whole thing will be resolved to 0. And similarly, we assign that variable to like the variable that p index is pointing at. Okay? So we set those two original variables in main function as 0 by dereferencing them, and then we loop through the whole array, rest of the array. We find whether any place is greater than or less than the maximum indexes in the maximum value or the minimum value respectively by using that index and finding that value. And if it happens, we update the original variables that max index and min index, these two pointers point to. Okay, so that's why after this loop is over, these two variables which we passed here, the addresses to, like mni and mxi, will hold the minimum and maximum address. Okay. So one more thing, like to us, it seems like the reason why we pass a pointer, okay, instead of a value, if we pass a pointer, generally it means that we want to modify the original value, right?
Yes, sir.
Yes, sir.
Means we want to modify the original value. But there is one more reason when we pass addresses instead of original value in function. Okay, so let's think of a hypothetical scenario. Like, let's say let's say we have an image, okay? This image is a data type in C. So like there is a data type, maybe we have built ourselves. We have an image data type, okay? We have an image called IMG. Now, images are really large, right? Whenever you take a photo, like instead of couple of bytes, they're in the megabyte size, right?
Yes, sir.
Like an image can be 3-4 in modern image, like cameras can be 10-20 megabytes, or if you're using like a DSLR and taking raw photos, they can be even like 400 or 500 megabytes. So 405 there, yeah, there are images that are 400 or 500 megabytes, like in case of environment captures, okay? So images can be very, very large in case. Now, what we want to do, like we want to have a function which which what it does, it shows an image, okay? It takes an image as input, okay? It takes an image as input, and then on your screen, it shows the image, okay? That's what this function does. It takes an image as input and shows it to you. Now tell me, whenever we want to show an image, basically we need to read the color values of each of the pixels, right? Basically we need to read the image, right? Do we define the image before showing it?
No, sir.
We just want to read the image to show it. So in that case, if we directly pass the image, again, we know that in C, how our values pass, like how our arguments pass to function? Pass by value or by copying, right?
By copying.
Yes, sir.
By copying. So if this image was 5 megabytes, and then I pass a copy to it, another 5 megabyte will copy in my memory. Is it correct?
Yes, sir.
Yeah. So one, I'm wasting my memory, and copying takes time, right? Copying 5 megabyte is like variable, which is like just 1 byte, or which is like 4 byte. Like if it is 4 byte, and if it is like 5, let's say even 4 megabyte, this thing, like this whole image is 1024 into 1024 times bigger than this one. This whole image is 1 million times bigger than just 4 byte, like just an integer. One integer, like one image is 1 million times larger than an integer. So it will take some time to copy. So as a result, our program, one, will become slow, and second, we are copying them unnecessarily. So if we show multiple images, we're wasting a lot of RAM by copying them again and again and again. So in that cases, what we can do, what can we pass instead of passing a copy of the image? What can we do? Anyone?
So pass the address of the image.
Yes. So pass a pointer to that image. Pass a pointer to that image. Now, as a result, I'm not making any copy anymore. Like if I pass the address, now the address is, again, in case of 64-bit operating system, it's only 64-bit or 8 bytes, right? 8 bytes just, and this one is 5 megabytes. Now this thing is like 50 million times, almost 50 million times smaller than this whole image, right? The thing that we are passing. We're passing the address of this image. That's the initial starting position of that image in the memory. It will just be a small number. So we pass the address. Now what we can do, we can go to that address, okay, read the value one after another, and show it in our screen, the colors, right? Is it clear?
Yes, sir.
Okay, so one final thing. In this case, are we modifying the image? Are we modifying the original image? No.
No, sir.
No, sir.
We are using pointers only to avoid copying, save memory and time. And the original image is only being read and not being modified. So what we can do, okay, we can basically declare, instead of declaring it as an image pointer, we can say that this is a constant image pointer. By writing constant pointer, what happens? We know in C, whenever we declare some variable as constant, we cannot modify them anymore. So like, let's say, void, let's just print one integer via pointer. Print int via pointer, and it takes one constant integer pointer instead of being integer. Okay, it takes one constant integer pointer, and we can write printf %d \n, and we can dereference the value of p. This is completely fine. We declared it again. I wrote dot instead of comma. Like this is completely fine. Okay, fine. But what does this const mean? This const means we cannot modify the variable that p points to. Focus on this sentence. We cannot modify the variable that p points to. That means we cannot write dereference of p is equal to 10. No, we will get an error. You see, expression must be a modifiable L value. It means p is a pointer to a constant integer pointer, then asterisk. So it means p is a pointer to a constant integer. So that means since p is a pointer to constant integer, we cannot modify the value that p points to. That's why writing this statement will be illegal. However, we can make p point to something else. That's completely fine. Like if you have integer j, we can write p is equal to and j. That is completely fine. We can change whatever p is pointing to, but we cannot change the value of the variable that p points to. That means we cannot write p is equal to like 5. Again, we cannot write it because p is a pointer to constant integer. Is this thing clear? So when we make this kind of promise, like in case of show image, we know like in case of those functions, like or in this case, like print integer via pointer. In this case, we know that we want to read the value only. We do not want to modify that value. We just want to read that. That's why we make it a constant integer pointer. So what happens if we mistakenly try to change the value of the variable that p points to in this function while writing, the compiler will catch that for us and tell us that, hey, you're not supposed to change that value because you already told me, you promised me that you're not going to change the value in this function. So you're trying to change the value of the variable that p is pointing to in this function. So you're wrong. Okay, is this clear?
Yes, sir.
That's why we declare a pointer as constant. Okay. There's one more thing I'll not show it to you. Like if we like one little thing, like if we want to say that, okay, no, p will not point to something else. I can modify what p is pointing to, but okay. So in this case, the constant will be at the right side of the asterisk mark, like asterisk mark. That means p is a pointer to integer. Okay, what kind of pointer? Now this is a constant pointer to an integer. In this case, I can modify the value that p, like the variable that p is pointing to, but I cannot write something like this is equal to and j. In that case, in this case, I cannot assign p to something new. Okay, in this case, the pointer itself is a constant, but this thing is not as necessary as the previous one. Like you will rarely see this one. So this is the more important one, constant pointer p. That means you cannot change what p is pointing to. Can we write constant at both the places? Yes. Okay, we can write constant lot of places. Anyways, this thing is more important. Like p is a pointer to constant integer. That means we cannot change the value of the variable that p is pointing to.
Sir, but I think asterisk constant p is also necessary for avoiding error because most of the time we would change the address unknowingly. So
generally, like what happens once a person like this thing, you can say that necessary, but this thing is like generally whenever we pass a pointer to a function, people do not like the works, like the works of computer science are such a way that once we pass a pointer to a function, it is rarely case that we reuse that pointer to assign some other values to it. Okay, so we never do these kind of things. Like pointers are already pesky things, so that's why whenever we need, generally we create different pointers for different variables. Okay, we do not use one pointer. Like though we can use a single pointer to point different variables at different times, we generally never do that. For each different variable we need pointer to, we create different pointers. So that's why this thing, the chance of this thing happening is really low, and that's why we generally do not like include the constant here, because that doesn't come. But very often it happens that we make some modification there. Okay, so that's why we declared like this constant integer, like it's more important. So one more thing, just like we can pass it to a function, we can do one more thing. Okay, we can transform return pointers to function. How? Let's say I want a function which will take 2 pointers as input. Okay, pointer to 2 integer variables as input. And what will it do? It will return a pointer to the maximum of those variables. Okay. So integer get max pointer, and it will take one integer pointer A, and it will take another integer pointer B, and it will return the pointer to the maximum of the variable, not the maximum variable, not the value of the maximum variable, a pointer to the maximum variable. Why do we need a pointers? Sometimes we want to do something with the variable that has the maximum value. So in this case, we return a pointer. What can we do? We can write like if dereference of A is greater than dereference of B, like if the value of A is greater than the value of B, like pointers, they are variables value, we can directly return A. A is already a pointer, okay? So we can write return A, otherwise we can return the pointer B, okay? So what will happen, like if we, in the main function, let's say we declare two variables, integer I is equal to 10 and J is equal to 20, and for now, like let's say this is an hidden variable, okay? I'm not declaring the type of PTR. PTR is equal to get max pointer of and I and nj. So what will this variable P hold? Anybody? Like if I is equal to 10 and J is equal to 20, and I call the function get max pointer, which returns a pointer to the maximum of the variable, two variables, what will this PTR hold? Let's say, also I'll give you one more thing. Address of I is equal to 2020 and address of J is equal to 3030. So what will PTR hold after this function is called?
3030.
Exactly. PTR will hold the value 3030. And what we can do, like PTR is equal to 50. So what will this thing do? What will this statement do? Asterisk PTR is equal to 50.
Change value of J.
Exactly. It will change the value of J to 50. Okay. So what have we done here? By returning a pointer to the maximum, like the variable with the maximum value, now we can dynamically say that, okay, so whichever variable holds the maximum value, I'm changing its value to 50 by using pointer here, you see? So this is an integer pointer. Integer pointer is equal to guess maximum of pointer I and J. So pointer will hold the address of J since J was larger than I. And here Peter is equal to 50. That means like now if I made I is equal to 30, what would have happened in line 19? Like this Peter will now get the value 2020 instead of 3030. And here instead of modifying the value of, now we're modifying the value of I to be 50. See, we are conditionally modifying the variables I and J using pointer. Okay.
Okay, sir.
Thing that you need to be careful about. Let's say we have a function, okay? A function that returns an integer pointer, okay? And it takes nothing as, let's say it takes nothing. And there we have declared one variable J and return the address of J. Okay. Can anybody tell me what's the problem with this function? This function is actually wrong. Can you tell me what's the problem with this function? Anyone?
The return type.
The return type is fine. We are returning address of J. It's supposed to be an integer pointer, right? And J is the address of J, which is a pointer.
So the variable J actually exists inside the function only?
Exactly. Variable J exists inside this function only. Let's say the address of J is 50. Let's say 50-50, okay? The address of J is 50-50 and it exists within this function only. Then whenever this function, like whenever we are inside this function and we have written this statement, integer J is equal to 10, what happened? Operating system allowed us to modify the value in the address 50-50 via the variable J. Now this address 50-50 belongs to inside this function. Okay. Now, whenever we're returning J and J, we are returning the value 50-50 here. Okay, we are returning the value 50-50 here. However, after that, this function ends, right? After that, this function ends. That means this address 5050 is now taken back from us by the operating system. As a result, we are no more the owner of this address. So afterwards, like inside the main function, okay, inside the main function, if we get multiplication main function, like inside the main function afterwards, if we tried, like let's say, okay, integer pointer p is equal to 2. Okay, thank you. If we like just try to print the value of integer pointer p, we will not get any error. Okay, we'll peeping at this address 5050, which has already died, okay, already been taken by the operating system. We can try to print the value. It might be 10, or it might be something else. The operating system could have allocated to some other program. The operating system could have cleaned it. It could have done anything with this one. If we try to print this value, we can get any value, and it can be garbage as well. However, problem will arise if we try to do something like this, is equal to 20. Anybody? Why this will cause a problem? Thing is that here we have declared the variable j is equal to 10. Let's say the address of j was 5050. This address will dynamically change, okay, while calling foo. So let's say this address was 5050, and we have returned this 5050 address here and got it in the variable p. However, this address 5050 belonged to j, and j died with this function. Whenever the call of this function was over, the variable j, okay, the variable j is destroyed, and the operating system takes back the address that was given to j. Why? It needs to be like resourceful. Whenever something is over, it needs to take back those addresses. Otherwise, you cannot accommodate so many things in your RAM. Your RAM will fill up really easily. If like whenever the use of one thing is over, the operating system destroys it. Okay, the whole system like that thing is destroyed. That's why once this function is over, the address 5050 does not belong to our program anymore. And now, if we try to modify that address 5050, like modify the value in that address 5050, we are trying to modify the value of a location that does not belong to us. We're trying to modify the value of a location that does not belong to us. So we are doing some violation, and the operating system will stop us from doing that violation. It can cause an error. The program can crash. Okay, the program might behave weirdly. Okay, like all other things that are done next will become weird. Or what can happen in the worst case, the operating system itself can crash. Okay, it would have happened in olden days, but in modern days, it does not happen. Generally, the program crashes. Is it clear?
Yes, sir.
Sir, does the value does the address 5050 contain any garbage value? Then
it can still contain 10. It can still contain 10. It can contain some garbage value. It can contain anything. We will not know anything because that address does not belong to us anymore, right?
Yes, sir.
After this function call is over, so let's say the program, another program is running. After this address, use of this address is over, like whenever a function is called and you declare some variable, these addresses are allocated dynamically. Okay, so what happens whenever this function ends? Okay, now this address is returned to the operating system. Okay, the program says, I'm done with this address. You can have it back. Okay, I borrowed it from you. You can now have it back and do whatever you like. Okay, now operating system takes this address and instantly sees that another program was asking for some address there, and the operating system gives it to that program. Okay, hey, you wanted one integer and I have this address. Okay, now you can use 5050 address. Okay, let's say this is program A and that one is program B. Whenever we are in this function, program A, like that address 5050 is given to program A. Okay, and the program A is done with the address 5050 after this function. So program A says to operating system, okay, I'm done with this address, you can have it back. Operating system takes it back and gives it to program B because program B needed it. Now, here, address A only, like 5050 only belongs to address A during this function call. And you have saved that address, okay, in pointer P. Now, you're trying to modify that value. Now, you are in program A, but does the address 5050 belong to program A?
No, sir, not anymore.
No, not anymore. It belongs to program A. So should program A be allowed to change the value in that address?
No, sir.
No, right? That's why this is wrong. This is erroneous.
Okay,
so
sir.
the thing is that a function should never return address of some local variable. Okay, remember this thing. A function should never return the address to a local variable. Remember this much. Never return address to a local variable. Some compilers will throw errors for this one. Okay. Finally, one little thing, it will take 1 minute. And that thing is that we can return to pointers to array elements as well. Okay. Let's say we want to find a pointer to the middle element of an array. Okay. So find middle element. For now, let's say the array is of like odd length. Integer array, okay, and integer n. Now, array of n by 2. This is the middle element, right? Like n is the whole length. Let's say if n is odd, like n by 2 is the middle element, right?
Yes, sir.
Okay. Now, basically, if I write something like this, it means the value of the middle element, right? Like if the array was 1, 2, 3, 4, 5, the value of the middle element is 3, right?
Yes, sir.
Okay. What if I write and array of n by 2? What does this mean? This means the address of the middle element. Like the address where the middle element, the value of the middle element is residing in memory, right?
Yes, sir.
By using, so we can return this address as well. Okay. Like we'll take a look at this thing elaborately in the next week. Okay. So basically what we can do, like it does kind of the similar thing as returning the middle index. We could have returned the middle index, right? Like n by 2, return middle index. Like if the array contains value 1, 2, 3, 4, 5, okay, like if you have an array, so 1, 2, 3, let's say 10, 20, 30, 40, 50. Okay, so what's the middle element? 30, right?
Yes, sir.
Okay, and what's the index of the middle element?
So 2.
The index of the middle element is 2. Okay, so like if we want to modify or work with the middle element, what we do, like if we know the, let's say, integer mid index is like if we somehow got the value 2, okay, somehow let's say we somehow got the value 2 using maybe a function. Okay, so what we can do, we can, if you want to modify that, we can write array of mid index is equal to 40. What will it do? It will change this value to 40. Like let's say, let's not make it just 40, let's make it 100. What will it do? It will change this middle value to 100, right? And the middle index, which is 2, and if I write array of 2 equal to 100, basically this value will be modified to 100. Okay, and what else can we do? Like integer pointer ptr to mid index, we can write like the function that we have used here, like find middle element, we can pass r and 5. And what will it do? It will return us an address to this thing, an address to array of 2. And then we can write like the reference of ptr to mid index is equal to 50. If we do this one, basically again, so is equal to 100. Basically again, we are changing the value of this variable. It's fine if you do not get this part right now. We'll take an elaborate look at this part in the next class, okay? This is what I have to say. That's all for today's class. Any question?
No, sir.
If there's no question, I'll take an attendance. Sorry, I'm already late, but I'll take the attendance. And once your attendance is over, you can leave, okay? So stop the recording. Ananto. So I'll call the names, and once your present is given, you can leave. And if you have some problem with your mic or things like that, you can write in the chat. Tamim will tell me the names afterwards. Okay, Abu Yana Shadid, Sharia Rashid Khan Sifat, Abu Zaad Muhammad Ridwan Hussein.
Present, sir.
Here. Tausif Tazwar Dipto.
Present, sir.
Asif Abrar.
Present, sir.
Asif Mahmoud Fahim. Darin Tasnim Ridi.
Present, sir.
Ahim Abrar.
Present, sir.
Chaudhary Blossom Ibn Rajak.
Present, sir.
Ardin Fayaz.
Present, sir.
Ehsanul Haq.
Present, sir.
Tanbir Chaudhary.
Present, sir.
Sir, Labib Muntasir miss করছেন.
Yeah, sorry. Yeah, Tanbir Chaudhary. Okay, thank you. Aryan Bashir.
Present, sir.
Iftikhar Zaman Ifti.
Present, sir.
Naim Mubashir Monim.
Present, sir.
Okay, you're back. Labiban Awar. Qazi Samin Yasir Alam. Qazi Samin. Okay, Khawaja Ismail Marian.
Sir, present, sir.
Sakif Kaisar.
Present, sir.
Radib bin Kobir.
Present, sir.
Yusuf Ibn Kamal Niloy.
Present, sir.
Miftul Al Siam. Mehdi Ahmed.
Present, sir.
Abdullah.
Present, sir.
Muftashir Ibn Amin. Mustafshir Ibn Amin. Mu'tasimul Doha.
Present, sir.
Maruf Ahmed. Samnun Asfar.
Present, sir.
Ramisa Zaman Audhi.
Present, sir.
Mahajabin Tabassum. Mahajabin. Mohammad Tamim Sarkar.
Present, sir.
Sadia Sultana.
Present, sir.
Adman Nayan, he won't be here. Merin Tazin, he won't be here either. Sadiq Salman. Sadiq Salman. Muttashim Kamal Dihan.
Present, sir.
Mosammad Jannatul Samaruk.
Present, sir.
Mushfiqur Rahman. Mushfiq. Saima Sittul Muna. Saima Sittul Muna. Sajid Hussain.
Sir, he was present. His
Yeah, he was present. Yeah. Okay. 140 Mushfiq. Okay. And 143 Nahin Siddiq, you were present. Okay.
Yes, present.
Tanvir Hossain Dihan.
Present, sir.
Samia Sharmin Tivana. Shuaib bin Hassan.
Present, sir.
Safwan Haq, you're here. Safwan Sakib.
Present, sir.
Okay. Sayan Ilham.
Present, sir.
Tamim Ahmed.
Present, sir.
Tanvir Ahmed Tanmoy.
Present, sir.
Sabbir Alam Saad. Tanvir Hassan Ananto.
Present, sir.
Munzer Mahmood. Munzer. Amina Arafa.
Present, sir.
Okay. Wasa Lutufi Sebania.
Present.
If your mic is working, you do not need to write in the chat. Arsalan Waqif Shah. Arsalan. Idris Farash. Idris Farash. Okay. Penda. Is there any way to contact with Penda? Like she didn't submit her media script. I mean, wait a couple of minutes after this class.
Okay,
Abdul Halim Hadaroni. Alom Alzin. Ibrahim Ahmed, Ibrahim Muhammad.
Present, sir.
And Suraya Nora. Suraya. Thank you, everyone. Everyone except Tamim, you can leave.
Assalamu alaikum, sir.
Walaikum assalam. Okay, Tamim.
Sir.